recording, and let's get started. So, just a quick background on myself. I have about 9 to 10 years of experience working with companies which have initially developed products for DevOps. So it's about 4 or 5 years back when DevOps was kind of catching up. To work with big organizations where we work with building the DevOps tools which many people use today, as well as from startups to mid-scale companies where predominantly our day-to-day job stays with DevOps. I'm currently a full stack engineer. I work for a mid-scale startup right now, and full stack engineer as in like we in our organization we do dev operations and all sorts of stuff as an individual user. And most of the organizations are trying to adopt this, and that's one of the reasons why DevOps is kind of catching up off the late. And there have been many people who are talking about DevOps, and obviously since it's a new field, there's a lot of interest. So
Yeah,
the focus of this session is going to be in terms of how the session's going to be, like what is the real need of DevOps, and where did it come from out of the blue, because it was not discussed earlier, and now why has it become such important thing, as well as for you we will talk about what tools we're going to discuss, what will be the primary focus during the sessions, and what kind of tools we're going to look at each section, and what are their benefits, why are they helpful, and so on and so forth. And also, your feedback will definitely help us in terms of anything that we should try different. But before I move on, anything specific that you are looking for, like what are you expecting from this session, so that I can see I can
so
move accordingly. Yeah.
I'll explain my background.
Mhm.
Like I'm working in a software company. Uh, so I'm working in basically Java domain.
Mm-hmm.
So I have around 8.5 years of experience in Java.
Okay.
Um, I just want to join the class for DevOps because we do use this DevOps, but
Okay.
I'm not sure about it.
Okay.
So, but we are using it. So, my role currently is like senior tech lead.
Okay.
So, yeah,
So your interest is not in terms of changing your domain per se, but you would like to understand like
yeah,
what
right,
exactly is
right,
happening in this one, right?
right,
Okay,
exactly.
very
Yeah,
well. Yeah, very well. Because I kind of come from the same background, so I can probably try to address if you have any questions. I'm also kind of a Java developer, moving on to various things, and we kind of live in a complex environment today. So, yeah,
okay,
please, if you have any question, uh, while I move this slide, like, just before I move the slide, I'll let you speak if there is anything. Probably you can get started. Like, when we are physically not present, it becomes a little confusing because I lose my train of thoughts and then I'll just speak about something else. So yeah, but just because we're in this environment, while before I move the slide, I'll let you speak. If there is any question, you can just feel free. We can discuss in detail about any questions that you might have. Would that work?
sure, please proceed. Yeah,
Thank you.
sure, please proceed.
Sure, thank you. So, since you're aware of the world, the environment that we are looking at, or where we are working, this slide kind of explains it by itself to you. This is more for people who are freshers, or people who have not got a lot of time to work with the real engineering team and stuff like that. So primarily, as you know, today, if you look at the organizations, we have development team, QA team, the operations team, which is responsible for deploying, and typically your network administrators, DB administrators, and those are the guys who stay in operations. We'll talk more in detail about the next slide. But yeah, so the code goes to QA, QA approves it, gives it to your operations deploys it for your customer accesses that, they're happy with it, they're fine. If they have an issue, they talk to your tech support, and that's where it comes back to the loop again. It can either, depending on the urgency of the issue, can go to either high priority, could go directly to your dev, or could go to your QA depending on how much time you have to fix the issue. Right, so this is typical life cycle of how an organization might work. Now, this might change a little bit if you're talking about a service company, because in service company, instead of your operations team and support team, you might as well have your on-site team there, and those are the guys who typically help you setting up the environment or talking to the customers, just in case if there are any issues, things as such, right?
Mm.
But yeah, this is the kind of infrastructure that we have. Nothing's going to change here, but the way things work are going to be a little different from what we see. Uh, but I'd like to know from you: is your organization also in the same lines, or do you have something a little different than this?
We have a similar kind of structure, but
Mm-hmm.
a little different than this because, like, I worked in a banking domain for about 6.5 years.
Mm-hmm.
So recently, I changed my company. So now I'm working in a PwC. So it was a product-based company. I'm working in the insurance domain.
Okay.
So our life cycle is pretty much similar to this, not exactly this,
Okay.
but I can understand this.
Sure.
Okay.
Sure. So let's try to look at more in detail about what is this or where we are involved, right? Like obviously it's we're not going to talk about support, we're not going to talk about customer management, then what exactly or where exactly does the DevOps domain fall? It kind of lies here. If we try to separate out the way products are today, you get into two main sections: your engineering and your operations specifically. So your dev and QA together, they form the engineering team, and the primary goal here is sorry, sorry. Primary goal of this team is to be able to deliver a product, right? It could sometimes be a simple product, or it could sometimes go a level higher for services team where they might extend their support to the customer even after whatever they're working on is complete. And then you have your operations team. That's where you have your DB administrators, network admins, system admins, and so on and so forth. Now, if you look at the world today, typically you would see a lot of system administrators or desktop administrators working with various organizations. Their responsibility is to ensure that the product is working well in these environments, and none of your servers are down, or they're having some sort of network delays or stuff like that. They take care of these things. But this was the a thing which happened about a decade ago, but now their work has gone a little higher than simply ensuring that the systems are up and running or the networks are up and running, and due to the advent of cloud. So when cloud came in, the teams had to work together, because operations team was also responsible for ensuring that the systems where the product is deployed are working properly, which means an additional aspect of monitoring product also came into the picture. Earlier they just had to probably monitor the systems, the network, the database, hard disk space and things as such. But with the advent of the cloud, where more companies are putting their product in on cloud as well as accessing products from the cloud, the operations team had to extend themselves and be sure to monitor the application as well. Also ensure that the third party products which you are dependent on, like for example, if you're working in a big organization and you're using Salesforce for your CRM product, or maybe Amazon for your daily provisioning, or systems infrastructure stuff as such. uh, just a second, just give me a second. Stop.
Yeah, sure, sure.
No, because there's only one person. No. Okay, I have sent you this. Can you send that link to me? Okay, sorry about that. So yeah, so
Yeah,
their job has extended a little bit, and what they have to do now has been more like ensuring that the infrastructure is maintained. That's primary goal of operation. So it extended from let me ensure that all of the machines in my organization or database or network in my organization is working fine or not, to ensuring that their infrastructure which is delivering the product, as well as this infrastructure whatever is it is using, like for example sometimes you're using Amazon as a web service, Amazon web services for your infrastructure, or some other service for some database stuff and things like that. They need to ensure that everything is proper and very well, right? And the life becomes very difficult because it was not as simple as one person managing 25 machines to 30 machines as in past, right? Like if you look at some of the organizations today, they have system admins who manage about 25 to 30 odd machines in shift jobs. Their job typically is to ensure that everything goes well. If you know about organizations like CSE and stuff like that, that's where their predominant job roles stay. And this culture is shifting now, because now the magnitude of systems have increased from 25 to 30 to thousands. Like for example, our organization, we have about 5,000 to 6,000 odd machines which have to be monitored, ensure that infrastructure is proper, health monitoring, everything, along with the application monitoring with just about 5 to 6 odd people, and that's all we have, right? We are in an environment where we have to reach to that level, and that's where it becomes more tricky in terms of how we solve this issue, because the regular operations team, the way they are, is not going to scale up, or is not going to really help. And we really need to see a way where they can basically do their job, uh, execute their job, not with more resources, because that's going to bring a lot of chaos. But since the machines are going to be added, and more machines are going to be monitored, and applications are going to be monitored as well, how do we look at it? So that's the aspect of where DevOps really helps in. So yeah, any questions before I move to the next slide? Okay, so moving on. Uh, let's look at existing process that we have with organization. Now, this is assuming the fact that the organization is already in a very good shape, right? Now, typically, if you look at some of the organizations where a lot of work needs to be done in terms of improving their stuff, you may not see continuous integration, or you may not see an operations team which is quantified enough to do deployment. Generally, operations team might rely on your QA team or your dev team to typically do the deployments rather than them doing it themselves. But let's look at existing process for organizations which are doing pretty well today. Uh, so they have one aspect of it which kind of is sorted out as of today. It's continuous integration. You might have seen this in your organizations as well. Like whenever a developer or some
yeah, yeah,
yeah, commits the code to source code management, a CI tool, a continuous integration tool, picks it up. The dotted line you might assume is a trigger, right? Like so, no one is invoking manually, but a trigger goes to continuous integration tool, picks it up, and then it uses the build tool, and the build tool basically takes your source code management, compiles the code, generates an artifact. Now, this artifact could either go into a repository, or it could go into a simple FTP or things as such, right? Your QA
yeah,
team picks it up from there, and they kind of start testing on it. Now, let's assume for simplicity of this session, I'm not going to complicate things by saying that your entire QA is automated. That's where we want to go, but if you look at the reality, a lot of QA is still manual today, unfortunately, and that's where a lot of work needs to be done, and we want to automate a lot of QA. But if QA is automated, even this process becomes fairly simple. We'll look at that, how it improves the things, right? And from there, from QA, if QA is approved, everything is well, and they kind of certify it, what they're going to do is, let's assume that for this discussion that operations is kind of your on-site team. That makes it really simple to understand this aspect. So QA approves it, gives it to your on-site team, and your on-site team finally deploys it. This is kind of existing process with continuous integration in place. It's a good thing to start with, but it does not completely achieve things as we might want to be. We'll see how the problems or where the problems come in. But in brief, talking about some of the obvious issues that pop up in this whole thing relies on this front. If you see, continuous integration is very well, assuming the fact that everything is proper. But once the artifact comes in, the moment you have some manual work here, QA picking up the artifact and starting to test things out, could be the first beginning stage of the problem, right? Like, how do we ensure that they're picking the right artifact? There could be a human error where artifacts are coming to your FTP site, but your QA kind of picks up an old artifact, or maybe they have certified something which was not even supposed to be the real thing, right? It does happen. Sometimes we often see your dev team or someone from your management saying, "Oh, we tested this build, but actually this is the artifact which was committed last night. So we have to test on this, not that one," and so on and so forth, right? It's a common issue that often happens with QA. And then the other problem is, how does QA transfer this to operations? There's a big loophole here, right? Whenever they're giving to your operations, typically you might see in real world that your QA sends out an email. They put the artifact in some FTP site, and then they let your operations or your on-site team probably know that this is the link. Please go ahead and deploy it for our customer so that he can see it in action. But since we're talking about a manual thing here, there are a lot of complications that could come up, right? Like, for example, uh, what if your QA shares a link and that's not the right one, right? Like what if the folder has been changed overnight, or the deployment steps which your QA has taken up is in a different document which is not part of the original artifact document which has been shared with operations. In which case, like, they might end up taking the right product, but configuration steps are wrong. So end of the day, the deployment is not proper, right? That could be another problem. And also with respect to your operations, now one of the common issues which we have with human beings trying to install or configure is the aspect of human error. Like, if I give you, imagine that I have 10 machines, and then I give the same exact document to 10 people, and then give them the exact machines, right? Like, same CPU core, everything, OS, everything same installation document, and then give it to the 10, give it to about 10 people, ask them to install and configure. End of the day, you will notice that the way the installation configuration has taken place is very different in each of the machines. Sometimes you end up running a wrong command. As a result, you might want to fix it. You might try something different. Sometimes you might get a command wrong, like folder name wrong. Anything could happen, and end of the day, the machines are not consistent. As a result, what happens is you need to hire more people so that they monitor that system and ensure that it is running properly, right? So, classic problem with operations, and that's the reason why you see, if you have an operations team, you might have noticed that whenever people are moving out, it's very difficult for your organization to cope up with attrition rate, because once your operations team who have installed and configured moves out, they also take away the information about what exactly did they do on that machine, right? And even though they have documents or things as such, no one is sure that they're totally updated and they're proper, right? Like, for your reference, another example is, what if one of your on-site team member leaves the organization? It's kind of very costly for your company, because he has done a few things with your customer, and if a new person has to join in and do it at the same level, it's going to take some time, right? And that's a big issue with respect to organizations. You cannot depend totally on entirely on one person, assuming that whatever he has done is proper, or the information which is not available or available only with him it will be shared with other people as time moves on, right? So those are some of the major complications which exist with the existing process. We'll look at things in more detail in the next slide, but any questions here? Okay, so moving
No,
on.
no.
Thank you. So yeah, let's talk about a few issues. Just a quick check here. Both of you have worked with Agile, or do you understand some basic aspects of Agile?
Yeah, currently we are under agile process.
Okay. I see another person joined. Kishore. Kishore, can you unmute yourself and please let me know if you are also you have.
Yeah, I'm also currently working in Azure projects and AWS. I'm currently working on AWS things.
Okay. Okay, great. So yeah, that kind of makes it a little simple for me. So let's talk a little bit about what is the problem here. If you, as you might have known, Agile primarily talks about how do you give a good product, right? Always all the aspects of Agile are tailored around how Dev and QA coordinate with each other, product management and stuff like that. But once a product is delivered, that's where Agile ends. But the DevOps problems start there, right? The entire issue is that you build an awesome product, right? Your QA test is very good. But end of the day, when you give it to the operations, these are the people who have never seen your product. They were not part of the initial development or testing. And then have you give an artifact to them and say that go ahead and install and deploy this product. You have followed Agile, that's very good. But when it comes to the operations aspect of things, Agile did not talk about how to do this, right? And let me just go to the full slide mode, just in case if you're not able to see the screen. Okay, is it any better? Do you see bigger text now? Hello. Uh,
Yeah, it's good. I'm able to see that.
Okay,
Yeah.
thank you for updating. Okay, so if you typically see the problem is that your development team is just consolidating development as your dev and QA. We're not talking at them as independent entities.
Hello,
Uh, Sorry, hello.
hello. Yeah, I'm Sidhu. Sorry to interrupt. I'm
Yeah.
not able to see the full screen.
What
So
was it?
it's struggling.
Okay. Do you see? Sorry. Okay. Uh, do you see any text which is not clear here in the screen? Just
It was in restore mode, right? It's not a full screen, right?
yes. How's it now?
Now it's okay. Yeah, yeah.
Okay, good. Thank you.
Okay, thank you. Yeah.
No problem. So, okay, going back. Okay, so yeah, like I was saying, so development team, yeah, let's join your dev and QA together and we call them as development. And then you have your operations team. And what is happening here is your development is following all agile principles and they are going sprint after sprint. And then they're giving, they're continuously pumping in artifacts for your operations. Now, let's remember that the operations team is responsible for deploying these artifacts in the environments which you have got, which means also that they are responsible for the infrastructure. Anything that goes wrong with the infrastructure is not the responsibility of development team to fix it. It is rather the operations team. uh, Let me give you a couple of examples to help you understand how it is, right? Like imagine if a new security vulnerability has been identified in HTTPS connections or HTTPS websites, and a patch is ready and it has to be deployed immediately, right? That's not the responsibility of development team, though they are the ones who have developed a website, the banking website per se. It's not their responsibility to patch the environments, but it's rather the operations team's responsibility to patch the environment. Now, however, let's say if you're working in a bank or banking organization, and one of your customer calls you up, your tech support, and says that he has withdrawn some amount, but it shows up as more than what he has actually withdrawn, right? And that's kind of an application issue and not an infrastructure issue. So whenever the issues come up, it could kind of be strange. Like, is the problem, we have to identify that is the problem with the machine, with the infrastructure that we have got. It could be at the web server level, database server level, network level, and so on and so forth. That's where it's the responsibility of operations to ensure that it is fixed. Whereas if it's an application level problem where your use case is not addressed properly, that's a development issue, right? Now, all the agile principles hold good, and it is given to your operations. But if you look at the life cycle, and if you kind of put the operations hat and try to see from their perspective, the problem starts here, right? Your development is saying that they want change because they're agile now, right? They're not waterfall anymore. They're saying that every 2 weeks or every 2 months we're going to give you new builds, right? And that's the principle of agile. We just got to keep pumping in new artifacts to you to be deployed onto production environments. And if your operation says, no, I want stability because that's kind of huge for me to take it at that pace, right? Now, it's not just one team who's going to continuously push the artifacts to operations team. Typically, if you look at an organization, it's a combination of many products that they build and in the same which are sitting in the same infrastructure. For example, let's take AWS, right? Like AWS has many services. It has EC2, which are like the virtual machines that you get out of them, and then uh, they have Route 52 to S3 bucket for storage, Route 52 to provision websites and stuff like that. They have a whole lot of products that the single organization is delivering, right? And the infrastructure which is giving out this product is the same one, right? Like they have whole bunch of data center servers sitting across the globe, and they have to deliver this product from all of those data centers, right? So it's their responsibility to ensure that these products are deployed across the board on
Yeah.
all the
Okay.
systems, right? Across the board on all the machines, and it becomes very difficult for them to manage at this pace where development is continuously pushing the things. So they want to say that they want the stability. They don't want the environments to be so fragile that they break every few deployments. For example, AWS does a deployment every 7 seconds. You might not notice, but their data centers globally can deploy a product if it comes to that. Like if you have to fix a bug or things like that, they can go at 7 seconds from the identification and fix of the bug to production deployment. Now imagine that being done by manually by someone sitting there in operations team, right? At the scale of Amazon, which is like, whole lot of machines, like about 1 lakh machines or more than that, right? Every machine being patched in less than a few minutes time frame. Now, so your operations team craves for stability, and then there's this classic wall of confusion where your development is continuously pushing things, and they say that your operations is not working well because of which they are not able to give new features because your operations team says they want stability and they won't let you deploy new products as and when they are ready. And your operation team says that they want stability, they can't take things at this pace with which agile is delivering products to them. So that brings in a few problems, and if you look at some points to consider, the top two are the ones which are primarily because of agile, right? So agile says your teams could be geographically distributed, but ensure that the scrum teams stay together. But it does allow you to geographically distribute the teams, which was typically not the case when during the waterfall days about a decade long or even a few years back, right? Teams who are developing a single product kind of stayed together, but now due to geographical distribution and the benefits which agile has brought in, it had kind of turned out that geographically distributed teams is a norm, right? Your QA could be sitting somewhere across the board, and then your probably engineering team is sitting in India, and so on and so forth. It's like a very common thing to see. And then the next thing is adapting to change. That's one thing which Agile keeps insisting on. They say that whenever your customer is asking something, Don't wait to build the entire product. Deliver in rather deliver in sections, get feedback from them, and based on that you can work on improving your product, which means that we're going to have more deployments before the actual product is actually ready, right? That's a strict no from operations. The other aspect is growing infrastructure, right? So because of the cloud aspect of things and the way people are getting acquainted with IT, you might have noticed that the infrastructure which people had earlier is not scaling anymore, right? We're talking about thousands of mobile devices to laptops to a lot of devices trying to access websites, apps trying to access the websites, and so on and so forth, compared to a few years back where there were, like, only a few universities or IT companies having a few computers, right? So those days have changed, which means that the product that you are developing should obviously be scalable. That's the application aspect of thing, but you also need more infrastructure, right? For example, take Olympics website, for example, right? Olympics website, in regular 4 years of time frame, never gets any hits, like very minimal amount of hits, right? Like when people are trying to just do a quick recap of things. But during the time when Olympics is on, you have so many requests coming in from millions of people, right? And this is the same exact problem which even Amazon had a while back, which brought together the world of infrastructure. We'll talk more in detail during the infrastructure session about why cloud is so important and cloud aspect of things, what it is doing, and so on and so forth. But primarily, we have identified that the infrastructure which organizations have today is not going to work, and they have to grow. When they grow, that brings up a new problem, because it would turn to be very costly if you have to procure space and machines together to deploy your product, right? For example, if I'm working in any organization, and my manager tells me that we have some new thing coming up for new year and a lot of people are going to visit our website, so we want 40 more machines from what we have today, then I have to see how to deploy. I have to think about procuring. I have to think about fetching new IP addresses for these boxes, and so on and so forth, right? A lot of cost associated with it, and obviously have hire someone to manage these machines. Now with the advent of cloud, all of that headache has gone. But still you have to manage the infrastructure which is growing. So how do you do that? That's one problem you have to consider. Geographical deployments, for example, if you're developing a product in the US, and then you have noticed that a lot of people from China are visiting the website, and there's a high level of traffic coming in from there. So how do you cater to that? How do you take care of that? You probably want to have a data center in China, because the requests are coming all the way from China through to the data center which you have in US, and then going all the way back, right? That's going to add some delay to your application, and your customers might notice that your product is slow. It's not that the product is slow, but the network has to travel all the way around the globe to just do a simple operation, right? Which is a very costly thing. So what you decide to have a data center in China itself to handle this traffic, so that the requests won't have to come all the way here, right? Now that adds a problem to the operations. How do they manage them? Because sitting in one location, they could at least go and fix some minor issues which come up in the infrastructure. But now they are having deployments across the globe, which means hiring more people in those geographical locations, and just the chaos builds up. Speed of development has primarily increased a lot due to agile, and as you know, the sprints go every 2 weeks or 3 weeks, and how do you manage at this pace is one of the bigger problem for operations as well, which we've discussed a while back. The next thing is development tools versus operations tools has become a big struggle. You might have noticed the people who are involved in development, they kind of whenever they get an issue, or whenever they have to fix a problem, they simply go to GitHub, or maybe somewhere outside, some blogs or some stuff like that. They kind of figure out that this tool really helps them to fix the problem. They use that tool and then they get it fixed, right? Or an issue addressed. For example, if you're working in a database related company and one of your developer figures out that there is an issue with Hibernate, maybe they want to use Spring or something, and then they just kind of figure out that in internet that the performance is very well, and then they kind of go ahead and use that tool. That's a development tool. Now, when it comes to operations, it becomes really difficult. Operation team says, "Oh, you're using Spring now, but how do I manage it? How do I monitor it? How do I know if Spring has gone down or application has gone down? How can I know about this?" Right? So they know they want a bit more tools than a typical development tool. So the kind of tools that are used for development versus operations are very different. They kind of want to monitor the machines, they want to monitor the applications. So they need specific tools that can help address them. Versus development is primarily looking at having a use case addressed, right? So that's their goal, and they're not worried about how do you manage or how do you monitor things. Which brings to our next point about monitoring. How do you monitor the product? How do you ensure that your application is running? How do you know if your customer, because you want to be uh, proactive than reactive. You don't want your customers to tell you that your application is down or they're not able to access a website. Rather, you want to detect even before something goes wrong and then try to fix the issue before your customer sees the issue, right? You want to be proactive than reactive. So for that, obviously, you need a lot of tools. And how do you monitor them? That's another aspect of things, right? Last but not the least, your licensing issues, or whenever you put infrastructure anywhere, what are the government rules there? For example, if you look at Australia, Australia says that they have data residency policy, which means any data of any citizen who belongs to Australia or an Australian citizens data cannot go outside the boundary or firewalls of Australia. Right? Let's say if your data center is in Singapore, so that you can your simple banking website or something, and you have your data center in Singapore, which means you cannot have Australian customers. If you do have them, then you need to put a data center in Australia. Now, this is strictly not a development thing, but it's an operations thing. So figuring this out is another big complication of operations. Also including are the licensing issues, which many of us are already aware of, right? Like when your development is using certain tools, or if your operations team is using certain tools, when do these licenses expire? Are the licenses proper or not? Because if there is a violation, your infrastructure is going to be sued, right? Like Microsoft is going to come after how many machines have a certain Windows operating system or stuff installed in them without having a proper license. That's kind of an operations issue, not a development issue, right? So these are some of the things. Does not cover the whole breadth of it, but just goes on. Like I can go about hours and hours speaking about the issues which people generally face, but these are some of the common ones which we're going to deal with. Now, before I move on, any questions? Okay. So how do we address this issue? So in order to address the issue, primarily we want to be like this than what we had previously, which was like this, right? We want to join things together, which means that we want to make our operations team part of our agile as well. Not just consider your dev and QA as your engineering team, but actually bring in operations as well. And that's where the birth of DevOps started. Let's take a quick example of it. Like, for example, if you're working on a new product and that product is you have decided during your planning meeting of Agile that a .NET application would suit very well. So you go ahead, you implement that. Your QA test said it's very good, and finally, after 2 weeks or so, after your Agile sprint is done, you give it to your operations team, and your operations team now comes back saying all of our infrastructure machines are primarily Unix based machines and we don't have any Windows machine. So where are you going to deploy the .NET application that you built because your infrastructure of Unix machines cannot run your .NET applications. So that's kind of very late to figure out, and although you have developed a very good product, it cannot be deployed, right? So instead of coming there, what we want to do is make operations part of your initial planning, initial design aspect of things, and consider deployment aspect of things during agile discussion itself. That's the primary goal. With respect to your engineering team, so if you're part of engineering, and you want to know what is the takeaway from here, or why should I exactly try to learn DevOps, the world which we're going to live is going to change now. And you will see that engineers are more like a full stack engineer, and you could actually take the responsibility of the whole thing, right? Like typically in organizations where we work, where you're not just a dev, you're also an automation engineer. You have to write automation code for the code which you develop, and also some aspects of operations to help deploy things as well. So you have to consider what infrastructure you have got, how do you deploy things and stuff like that. Yes, you will have someone from operations team to help you during these discussions, but that's more of an help. What we are talking about is when you develop the product itself, you are thinking about operations. That's the primary cultural shift which is going to happen in the dev aspect of things. With respect to operations, if you are planning a role for DevOps, or if you're planning to dedicate a role as an operations engineer who's a DevOps engineer as well, for you the thing is that you need to understand the development aspect of things, because unlike the old days where you were managing 25 to 50 machines per single person, now we're talking about application monitoring added for thousands of machines with just a single person or maybe a couple of people, not more than that, right? And the infrastructure could just keep on growing, but it doesn't mean that we're going to hire more people. Rather, we need automation there so that it is taken care of. Now, when we talk about automation, obviously it means code. So how are we going to write code? So the win-win situations for situation for operations team here is they learn some aspect of development, right? That's why if you look at the DevOps courses in general, they have development aspect of things as well as operations aspect of things, so that both the teams get benefited, right? Your development teams tries to learn about infrastructure, operations, how things get deployed, how do things work, and so on and so forth. Whereas your operations team now can help make their life easy by automating a lot of things rather than doing them manually and running on shift jobs. They can write scripts now to help manage the infrastructure. Okay. So let's look at how does DevOps transform the original cycle which we saw a while back with the existing organization. So your continuous integration is going to stay, but we're going to add a few modules to it, which is continuous deployment as well as monitoring. Let's see how it goes. So it starts with the same level. You're going to have an SCM. And while I talk about this, I'm also going to talk about some of the tools which we will see during the course. What tools we're going to consider at various levels of DevOps pipeline, we call this, and what do they help in actually. Okay, so during this in the source code management, we'll look at SVN and Git. I guess you have a fair bit of knowledge on what these are. They're like basic source code management tools, help you collaborating code together when you're working in teams, and also version control and stuff like that. Then you have the build tools, which we will look at Maven for the build tool. But in order to trigger the build tool, we will look at a continuous integration tool, which is going to be Jenkins in our case. And when I say continuous integration tool or a continuous deployment tool, I don't mean that it is actually deploying or it is actually integrating. It's rather helping you to do that. And we will try to use Jenkins in all aspect of things, like whether it comes to continuous integration or deployment. We'll see how Jenkins will help us achieve this. And so what happens here actually is you commit code into your repository, and from that repository, a trigger is sent to your Jenkins, which is the continuous integration tool. It picks up the source code because it has access to the source code, and it kind of triggers the build tool to compile and generate an artifact out of it. Now, obviously, the source code which you write will have some certain dependencies. It could be on a third-party dependency, or it could be like an internal dependency on some product that your other team has built, during which it has to resolve the dependency. And for that, we're going to look at artifact repository. It's really beautiful. if you have worked with Nexus or things like that, it's kind of similar to that. But JFrog is much more than Nexus. You can use it for various other things like Docker images and backgrounds and stuff like that. So we're going to try to cover JFrog in the course while we proceed. Uh, uh, Primarily because of its popularity and the way it is scaling up, and more people are trying to use JFrog. Now from here, once your tool has built the product, it's going to push it back into your artifact repository. So it's going to look at your artifact repository for two things. If it's dependent on something, it's going to take that from artifact repository. Once it has built the artifact, it's going to put it back into artifact repository. From there, your continuous integration tool is going to notify your QA team that there is a new entry into the artifact repository. Please go ahead and check. Now this, I have separated out QA as a manual thing here, but typically if you look at an organization, this job could be automated. Like if you have an automated jobs, once the artifact is available in JFrog, your Jenkins can start a QA deployment, and once the QA deployment is done, it will trigger the automation jobs to ensure that the QA is done properly. But just for simplicity, we'll just consider that it sends an email to QA so that they get notified and they'll start testing. If they approve, they can trigger a job back in Jenkins again, and that's where your Jenkins doubles up as a continuous deployment tool as well, which will trigger a deployment tool, right? So everything is done by your deployment tool. Your Jenkins is primarily acting to trigger a new job in your deployment tool so that it can deploy your artifact into the infrastructure environment that you have got. Now, the infrastructure could be your sandbox, it could be your QA, it could be your production. Depending on which job is triggered your Jenkins, it's going to push your artifact accordingly into that environment. In those aspect of things, we're going to look at Chef and Puppet in detail about how they're going to help you in achieving things. Last but not the least, if you look at the cycle back here again, your support team goes through a very bad time, because at least your operations team had some benefit during deployment. They know a little bit of the product, but the product knowledge has always been with your dev and QA. Your tech support team has no knowledge about what was the product. Just that, your customer gives a random call to them and starts saying that this product is not working, and they're kind of puzzled. They have no clue about what this product does or how does it deliver and what happens, right? So it's a really difficult problem, being a tech support for things which you have no idea about how they work, and that's where monitoring tools help in, right? There is one another aspect of things which I kind of missed to cover here, is who manages your infrastructure. Obviously it's operations, but your operations is never going to let your development team touch any of the machines. They're never going to let development team touch any of the production machines, whether it is to check the logs or change a file or anything simple. They're not going to let you do that. Rather, they would do it themselves, and they will just tell you that, just schedule a call and then we'll do it for you, because they are the ones who are responsible for infrastructure. They won't let development have access to the environment, which brings two problems. Problem one being, if a developer does not have access to the infrastructure logs and stuff like that, how are they going to debug and fix an issue for your customer? And the other aspect of things is your support team, because your support team is becoming a reactive way of handling things. They don't know about the problem unless your customer tells you that there's a problem. How do we address these issues? And that's where monitoring tools really help you in. The monitoring tools are at two levels. One is at infrastructure. So if there is any problem with infrastructure, machine down, machine being down, or hard disk being full, they can detect and they can send alerts. That's one aspect of things. The other aspect is application log monitoring. So all the application logs, whatever, like your banking application or whatever you build, all the logs, instead of giving access to the infrastructure or the machines, your operations team will channel through all the logs into a separate machine and give the access to that machine to your developers. So then they can go there and try to see the consolidated information. Now, it is not as simple as I just described today. It's kind of very complex, and we will look at it in more detail when we talk about monitoring tools. But with respect to this session, we're going to look at ELK at this aspect of things, like how ELK is going to help in monitoring or application log monitoring. So moving on, uh, tools and languages that are part of this course. Now, this is not completely exhaustive because I didn't want the slide to look really messy. But just a few aspects of things, some things which we've already covered, like Subversion, Git, Jenkins. We're going to have Maven, Chef, and Puppet. We talked about JFrog. Obviously, since this is an aspect of automation, which means that your operations team is going to learn coding now, we'll need some part of scripting as well. So we're going to look at Python and Ruby. We will talk extensively about Python because that's really key important aspect of things when it comes to DevOps. But Ruby will be short. Ruby courses are primarily targeted towards Chef and Puppet. Whatever you need to know in order to write scripts in Chef Puppet, that's where we're going to look at Ruby. Now, there are a few more things, like we're going to talk about infrastructure, and that's where we're going to look at a few more tools which are not part of the slide. For example, we're going to talk about Vagrant, we're going to talk VirtualBox, how do you set up environment, how can you convert your laptop into a data center of its own with those products. We're also going to talk about some cloud aspect of things. That's where Amazon Web Services or AWS really helps in deploying infrastructure to we're going to primarily look at how do you provision machines, how do you use your AWS instances to in real world, how do you give permissions to the machines, and those side of things. We're also going to look at Docker containers, how they help your environments to build, and how why are they fast in terms of infrastructure and things like that. We'll talk more in detail about them. Things which are not part of the slide, which we will also try to cover, are certain aspects of regular development and other things like the web servers. Like we're going to talk about Apache web server, Nginx web server. How does it work, and how does it help you in setting up the environments, and how do you monitor them? Because web server is an aspect which operations handles, or the primary responsibility as an infrastructure, not as an application. Unfortunately, few people look at it like an application thing, but web server is really an operation side of things. And we will also look at some DevOps best practices, and what you should consider if your organization is moving towards DevOps, things like that. So I'm just going to pause here. I know I jumped a few slides for questions because we were running short of time. So if you have any questions, I can take them now. Hello, any questions?
Yeah, I don't have any questions. It's a good currently.
Sure, thank you. Okay, so
Yeah, I'm good to go as well.
okay, I I think I'm kind of done actually. So I wanted it to be a little short. I didn't want to get into any topic because if we get started, then any of these tools or aspect of things are going to take at least an hour for us to discuss in detail. So before I move on to few more things, I'd like to check with you if you have any expectation, not questions from slide, but please let me know your expectation from this course, so that I can help you address if we're going to cover that or not. If not, then what can we do, and so on those things.
Yeah, currently actually I'm working very closely with the DevOps team
Mm-hmm.
in AWS. So we are building a product in Cisco. So I'm currently closely working with the these things, the DevOps with the DevOps team. So I just have questions because AWS is a last, it's a cost wise, right? So
Mm-hmm.
every time my manager and everyone will say that how can we reduce the cost?
Okay, so
I mean, deploying services. I mean, so many people will be deploying a lot of services in dev and int and production. And production means int, whatever the int artifacts is there, they will promote to production.
yeah.
But as per the cost wise, DevOps team will do anything.
So yes, cost is a very very important factor of DevOps. Like if you look at in general about what actually stands out, tools, they're generally going to stay about a year or two, and then they'll change. So tools aspect of things is not the real thing, but I keep insisting on two facts to people who I train on DevOps. One being, can you try to see if you can minimize the cost for organization? That's a very important aspect of things. The other one is how best you can monitor so that you are proactive than reactive. Like if any problem in infrastructure or things like that, can you detect even before your customer detects that? Now coming back to your question about Amazon Web Service being costly, let me just correct that a little bit. Like Amazon AWS is like really cheap. Like if you move to any other service which is going to provide you infrastructure, you're going to notice the price difference that Amazon has. The problem which you might be noticing is probably because your organization is not managing properly, or there could be that there really is a big need of a local data center than AWS, right? Like if you look at it, like for example, if you have to rent a bike versus buy a bike, right? Like for example, if I'm trying to if I'm going to stay in Hyderabad for about 2-3 years, and let's say if I rent a bike with about 5,000 a month, that's going to be an unnecessary cost for me, right? Because just about 10 months money, I can very well buy a new bike for myself, right? So that's whereas if I keep on renting it for about 2 years, I'm losing there. And that's probably could also be happening with your AWS, right? Probably you have a requirement for a local data center rather than an Amazon Web Service, and because of which you are renting a machine more than the cost of the machine itself. So you have to properly identify where the issue is. But if the focus is about having a cloud based solution, then AWS is the best. It kind of has a very minimal cost compared to other products that we have in the market today.
Okay.
Right. But yeah, we will discuss in more in detail during the infrastructure sessions about where people often make mistakes, and yeah, and more in detail about when we're going to purchase an Amazon instance from Amazon Web Services. We'll see what kind of configurations are very common and people don't change, but they could in turn end up being more costly for your organization. We'll look at that as well.
Okay.
Yep. Any other question? Okay. So yeah, we so just a quick thing on how the course is going to be. We will have more of I insist on a lot of hands-on than sharing a lot of documents with you, because obviously those documents are going to just lie around, and we'll just visit them whenever we want. So primarily the focus is going to be in terms of I show about a couple of hours a day during the weekends, trying to tell you the importance of these tools, and also some scripting wherever the scripting comes into the play. We'll try to set up environments, and the documents which I'm going to share with you are primarily going to talk about how to set up these things yourself, right? So the focus is not a lot about what is this tool or what does it do in the documents, but rather to help you get started, to help you configure yourself, and try to see how they work in real time for yourself, right? That's where those documents will help you in. But obviously after the class you will have enough time over the week to experiment, try to see how things work. And when we're going to talk about, or the over the course of time, I'm going to show it myself. Like I'm going to tell you how we are going to install, configure, and what is happening. How things are working. In terms of labs, or how do you set up a lab for yourself? If you have a 4+ GB of RAM in your laptop, that's kind of enough. And you might want to have an AWS account for yourself, because we're going to purchase some machines from AWS. And if you have if this is the first time you are purchasing an AWS instance, or you don't have an AWS account before, then that's very good, because you're going to have machines for 12 months for free, about 750 hours a month. That's kind of enough for regular tests that we generally perform. And you might need some more accounts, like a Chef account and a Puppet account, a Docker account, and so on and so forth. A GitHub account, obviously, and we will talk about it when the things come in. So you're going to see how things work, and then you will receive a document with respect to how what we have done, or how can you set it up yourself. You will see that in action, and you can please feel free to drop any question to me. You don't have to wait for the weekend to come back and then talk about the questions you might have. But we will have a dedicated time every 2 hours, probably in the last 15 minutes or so, to see if you have any focused questions in terms of what happened in the previous labs, or probably you had an issue with setting up your infrastructure or things like that. So we'll try to cover that. But yeah, the focus will be on you doing it yourself, and me helping you to see how you can do things. Like, I'm going to show it myself how I did, and give you a document, and then you can try out and tell me what happened with it, or if you have any specific questions. Okay.
Yeah.
So I'm
Hello.
kind of, yeah. Please go ahead. Sorry.
Yeah, actually, I'm just my organization has given me some good opportunity to promote myself up at the level. So
Mhm.
that's the reason mainly I was concentrated on this course. Yeah.
Okay, sure. So that since you are a developer by heart, so it really helps you, like, because some of the aspects of scripting and stuff like that become very obvious to you, and you will be able to break through them. But certain aspect of things might come a little new. Like, for example, when I talk to a few develop people who are from development background, once the continuous integration aspect of things is are done, it kind of gets a little complicated for them. They kind of with AWS, Docker, Chef, and Puppet. That's where the things get a little complicated. But since but the good news is that all of these are scripting. They are controlled by automation, which means that if you can write code, you can control any one of them. And since you can write code, kind of makes it very simple for you. And yeah, it becomes like a flow from there. Yep. So if there are no further questions, I'll stop recording now.